get started. Off we go. So I did click record. Yes. Okay. So let's finish up these loop slides. I only have 2 slides left, but they're actually going to take a little time to talk about. It's very fun. So it's a nice combination of everything you've learned. So we know how to make programs that repeat things now. Let's make something fancy that repeats. All right. Let's make a graphing calculator program. All right. This is going to be our next lab anyway. I would like to graph a circle on the terminal. All right. That's my goal. I want to make a circle on the terminal. This is the equation for a circle. Hopefully we've seen that once before. We're going to use that to our advantage to actually graph a circle, just like of stars or something on our terminal. It won't be perfect because you can only use characters there. You can't like plot images, but it's going to be close. It's going to be cool. It's going to be large. So let's the default size of most terminals is like 80 by 24. So let's graph in a 78 by 24 area. Why not? And so I promise it's going to be very similar to drawing a box. So let's draw a 78 by 24 box, and we're going to turn that into a circle. All right. Let's do that first. I'm going to call this program graph. It's going to be very fun. So I'm going to draw a 78 by 24 box. So remember that int I equals 0, I is less than 24, I plus plus. This is worrying about what line we're on. And then the J one, the inner loop, is worrying about what column we're on as we're printing stars, because I want to print a 78 by 24 box. J plus plus. So see out a single star on each line 78 times, then a new line. And then if you just repeat this 24 times, you got 24 lines of 78 stars. Okay? Any questions about that? That's the program. It's going to be hard for me to show it to you here because I'll have to zoom out a lot. But let's run it. Let me zoom out a ton and I'll run it. Whee, there it is. 78 by 24 box of stars. Or sorry, 24 by 78. 24 lines, 78 columns. Any questions about how I got this code? Because we're about to make it much fancier. So it's coming back to us, printing something by something box of stars using a nested loop. So that's the fun start of it all. And now notice that if we were to translate this into like a graph, we just made a box of stars, and the width of the graph was 78, and the height was 24. So the width was 78, and the height was 24. If I can write an 8 today, h equals 24, let's say. Notice how, as we were arranging, like we were printing stars going left and right, that was J's job to go left and right. Yeah? So it's working like our x coordinate. Ooh. And then it was I's job to figure out what line we're on, and that's dealing with up and down. That's like our y coordinate. So I is just like y, J is just like x. Ooh. Let's change those. So you are y. Not I anymore. Y plus plus. You are x. X is less than 78. X plus plus. See where I'm going with this? It'll do the same thing, they're just a different variable name now, but that's what they're functioning as. This is like ranging from left to right, and y is helping us figure out what line we're on, so it's kind of going up and down. So it's just like those things. So, all right, this is how we're going to graph. Let's assume that our graph's window looks like this, 78 by 24. The goal is to have the origin of our graph in the middle, right? If I want the origin of the graph to be 0, 0, right in the middle of our output box, I want that to be 0, 0, then I can just have x and y range in a certain way so that in the middle of them is 0, 0, right? So I need to have x go between not 0 and 78 now, but how about start at negative 38 and go to positive 39? That can be the left and right, because then right in the middle would be 0, x equals 0. Does that make sense? it's still ranging through 78 things, but now 0 is in the middle of the range. That's the goal. And I can do the same for y. Like, it's got to be 24 high, so let's pick a half. Like this can be y equals negative 11 at the bottom. This can be y equals 12 at the top. Does that make sense? So now 0, 0 is in the middle. Y equals 0 is on the middle line, and x equals 0 is the middle column. Does that make enough sense to us? So I'm just going to change the way that these variables range. They're still going to do the exact same thing still. So y, we start printing up here. So y should start at 12 and get smaller, actually. Y needs to start at 12, get smaller. Y is greater than or equal to negative 11. Y minus minus. And then x is increasing from left to right, but it's starting at negative 38 and it's going to positive 39. Less than or equal to positive 39. So again, I have not changed a thing. I've just changed the way that these variables have range. They're still doing the same stuff. I'm still going to get a 78 by 24 box of stars if I could show you all of it. Okay? Any questions about the code so far? It's just still a box of stars. I've messed with the variable names. I've messed with the numbers they're ranging through, but the total numbers are still all the same. Because now I can do cool stuff. Because now 0, 0 is in the middle. Maybe I can draw a little plus sign to indicate that I'm in the middle of my graph instead of a star. Watch. So if x is 0 and y is 0, that means we're at the 0, 0 coordinate. Those are our variables. And I would like to output maybe a plus sign to show the axes meeting. Otherwise, I can do a star because I'm somewhere else. Now watch. I will have to zoom out for this, but recompile, rerun after doing this. Whee! I don't know if you can see it, but there's a plus sign right there, right in the middle of my box. So now I can use x coordinates and y coordinates, and they look to be in the right place. And so now I can graph around this origin. All right, that's going to be the goal. So now I got a plus smack dab in the middle there. And so let's see here. I think that's where I want to be for now. Any questions about this code? So I've changed the way that these variables work, and I've noticed that if I'm at 0, 0, I want to print a plus, otherwise print a star, and the way that I've ranged between x and y is I'm getting that plus right in the middle of my box. That's pretty cool. All right, so the goal is going to be to draw a circle around this origin. It's going to look like this, just like a circle of stars, something like this. And so we're going to need the equation for a circle in a second. That's x squared plus y squared equals r squared, if we remember that. And that is going to be our goal. And we kind of need a blank slate, right? We're either going to put a star if it's on a graph, or like we can keep the plus if it's not on the graph, if it's the axes meeting. But everywhere else, it should just be empty space, right? We don't want to plot stars usually. We want to save the stars for the graph. So, dun, dun, dun. So this is the, this is the axes meeting. And this is, like, everything else that's not plotted. Let's just make that a space, empty space. We still need to move the cursor over so we get the right character on the next coordinate, but empty space otherwise. All right, so now I change the stars to empty space. If I run this, I see just a bunch of spaces and then a plus sign in the middle now. All right, so that's where I am so far. And so it's just going to be another if statement that just checks, are we on the graph of the circle? If so, put a star. Otherwise, check for this. Otherwise, check for this. It really is, once you get it, like it's pretty simple, but it's hard to wrap your mind around it first. Super cool, right? But we're doing this ranging. This is our goal. Okay, so let's say that we're going to graph this equation. Let's graph a radius 10 circle. So x squared plus y squared equals 10 squared. That's going to be our equation. And so it's going to look like this. So we got a little circle, 10. So here's x equals 10, y equals negative 10, x equals negative 10, y equals negative 10, and then y equals positive 10. Those are all going to be touching the graph there. And again, this is what we want it to look like. We draw a bunch of spaces, plus sign, and then like stars around that. That is what our graph will look like. Okay? So, okay. In order to graph on the terminal, we just need to figure out like which of these coordinates, because we're ranging them over all of them, right? Nested loops try all the possibilities. We're ranging over all the possible coordinates within this range. We just need to figure out if our current coordinate that we're looking at right now inside of our innermost loop is part of the circle, right? And so we're just going to check. All we got to do is like take this coordinate that we got an x value and a y value right now that we're looking at, check if it's on the equation, if x squared plus y squared equals 10 squared. That's what it means to be on the graph, right? That's the goal. And we'll print a star if it's there, right? Sadly, this doesn't quite work. You can't just check if x squared plus y squared is exactly equal to 10 squared, because some points on the graph, like over here, involve decimal places, right? And we're only ranging between whole number x and y values. So there is something we have to fix there. We're going to have to like shove the point into the closest whole number, and that will involve rounding, okay? So, but at a high level, we need to do something like this. Like we have x squared plus y squared, and we want to graph it if it's equal to 10 squared. For reasons, let's plot so that every x value has some y value that is the closest whole number. So let's solve for y here. Let's solve this equation for y. So y equals, you got to bring the x squared over, 10 squared. Most equations don't have x and y on the same side anyway. Subtract the x squared, and then you got to take the square root, right? And so the answer is y is equal to plus or minus that, if you do it in this form. That's really going to be the two equations that we graph. That's going to make it so that every x has a y that it goes to. This will make sense in a second. So, all right, that's what we noticed. So if we have a coordinate, x comma y, it must be plotted on our graph, needs to be plotted, if the y coordinate is equal to, this is now C++, it's equal to the square root, right? Let's do the positive half. The square root, I'll put this over here because I need to add something. The square root of 10 squared, I'll just do 10 times 10, minus x squared, x times x. And this will tell us if it's on our graph, if this is true. There's something secret I need to add here still, though. So does this make enough sense? Like if this corresponds to this circle equation. If this is true, it's a point on our graph. And then sadly, we have silly decimal issues because like points over here on our graph are probably like 4.5, 6.789, and those are not whole numbers. Our x and y values are only ranging through whole numbers. So if we want to have something appear on the graph, we gotta like shove it to the closest whole number y value, let's say. And so we gotta round it. We'll just round it to the nearest one. It'll look a little bit off, but it's close enough. So because we're using x and y values that are only whole numbers, we need to squish. Oh, this will make sense once you do it yourself. You need to squish decimal places onto integer coordinates, the closest integer coordinate. But for every x, there is a closest y value, and that's the one that we're going to map it to. I hope that makes enough sense. So if I can just legitimately type this out as an if statement, put a star if this is true, I will get a circle. I'll get a semicircle, I'll show you. So here we go. If y is equal to rounding the square root of 10 squared minus x squared. So legitimately what I just had. And I need CMath for those two functions. If this is true, it's on the circle. The top half of the circle. Oh gosh. There we go. Top half of the circle. So if it's on the graph, I want a star. Otherwise, maybe it's the axes meeting. Otherwise, it's none of that. And let's just keep on going. There's nothing to plot. Put an empty space so that we're ready for the next coordinate. right? So that's the new code. Here I am. If x and y match this equation of this circle, put a star, all right? And that's going to do exactly what we want. It's very satisfying, watch. So I can't show you everything at once. It's too much going on. If I run it, ooh, I get the top half of a circle. Look at it. Every x has a corresponding y, the closest one, rounded to. So you see like there's some corners going on here. There's no, it's very pixelated, I guess, is how you can call it. But every x has a y, and that is half of a circle. The reason it's a little squished and not a perfect circle is because look at every character on the terminal. It's twice as high as it is wide. So it'll be squished unless you somehow account for that. But that's half of our circle. Are there any questions about that? Why this code drew something cool? Are we good with that? That's so fun. So that's that one. Let's do the bottom half, because it was plus or minus the square root. So there's a minus square root at 10 squared minus x squared to plot still. So if it's not the top half of the circle, maybe it's the bottom half. So else if the y is equal to all of this, actually. Let's just copy and paste. It's just y equals the rounded negative square root of all that. So that's the other equation. If that's true, it's another star. Oops. What is going on here? There's some lag today. Okay, so if it's in the top half, print a star. Otherwise, it might be in the bottom half. Check that too. Print a star if that's true. Otherwise, maybe it's the axes meeting. Print a plus sign to show that. If none of that's true, just print an empty space so that we're ready for the next coordinate. All right, so that's the new code. That's the final code. And if I compile and I run, I get a beautiful circle displayed. Wow, look at it. Stars and plus for the axes meeting. And so every time we're within the body of that innermost for loop, we're printing a single character. It's either a star or a space or a plus. We need to print something so that we're ready to have the next coordinate in the next spot. Can't just like print nothing, otherwise it'll all be jumbled together. Gotta remember those spaces. But that's the final output. Look at it. It's so pretty. Are there any questions about this code? Might just be something we gotta look at hard for a while. But I tried my best to explain every reason, every piece of why we did it this way. We happy? Do ask questions, because you're going to be doing this on your next lab. You're going to be graphing stuff. That would always make it positive, though. Yeah. We need negative y coordinates for the bottom half of that circle. Right. We would still be counting at the spot. Oh, I see. Checking if the... Yeah, that would totally work. That's a good point. Because it's symmetric. Yeah, you could totally do it that way. Good idea. You could also just shove both of these like as an or in the same if statement. If this is true or this is true, print a star, because you're doing the same body. That's another option. But yeah, millions of ways to do the same thing. Here's one. All right. So I think that's a fun example. I hope that you will enjoy it in your lab. But that's the end of loops. Any last questions about these guys before I go into something completely different? All right. So next piece of today, I want to talk to you about arrays and vectors, two similar concepts in C++. Okay, so they do the same exact thing. Both of them do the exact same thing. They hold stuff, all right? We know how to hold some stuff. We know how to, this is too thin. Let me fix my pointer every time I open new slides. It's unhappy. Okay, now that's too much. This should be just right then. There we go. So arrays and vectors are ways to hold things. We know how to hold things in individual variables right now. But arrays and vectors allow us to do something like this. Kind of like how strings can hold a bunch of characters at once. arrays and vectors can hold a bunch of anything at once, maybe a bunch of ints. So, and the moral of this story eventually is that vectors are much better than arrays. They're cooler. You always want to use a vector if you can. Sometimes, for reasons like multi-dimensional things that I'll show you soon, an array is a better idea. But usually you always want to go with a vector. It's going to save you. Yes?
Can an array store multiple strings?
Yes. You have an array of strings. And we can get into that. It will fall out of the syntax once I show it to you. It will make sense. Yeah, any other questions? So it's just a way to hold a bunch of stuff. That's all they are. Arrays and vectors. Two different ways of doing the same thing. Arrays are the old way. That's the way from the original C language for every programming language. It's very low level, very simple. They exist in C++ too. But what they are, I want to teach them to you because vectors are like a better version of arrays. That's why we're going there first. So it's all about holding a bunch of stuff of the same type. All right? So here's like an example problem that would be very hard for you to solve right now. Let's say that you wanted to ask the user for 50 numbers, and then you want to print out each of those numbers that the user typed to you in the order that they typed them to you. Right? So that would lead to a very disgusting program. You'd be like, all right, I got to make 50 int variables, and I have to see into each of them. That's a very long 2 lines. Hopefully you'd split it up, but loops can't even save you. You need 50 separate things. That's no fun. We don't like that, Sam I am. So what we're going to do instead is we're going to package them together in this thing called an array. So if you look up in the book or something, an array it's a variable. It's a thing with a single name, but it's going to hold a bunch of stuff at once. Holds a list of data items of the same type, each being directly accessible. So some interesting things going on there. So each piece of an array is called an element, we say. Some new terminology. And what directly accessible means is you can go to an index into your array, just like you can go to an index in a string and get to an individual character. You can index into your array. The operator looks like this, using brackets rather than the .at, and that will give you a piece. All right. And here's an example. Here's an example declaration of an array of ints. You just put some brackets and then maybe a number. So you read this as, the syntax is a little weird, but the name is here, R for array, I guess. Give it any name then. R is an array of 7 ints. So that's what the line just did. It made an array of 7 ints and it called it R. All right. So in memory, what's going on is it just did this. It made a big long box that holds 7 separate things. 1, 2, 3, 4, 5, 6, 7. And they're each directly accessible, which means we have indices, 0, 1, 2, 3, 4, 5, 6. They start at 0, of course. And I didn't give a value for any of these things, so as usual, they're all set to question mark right now, all these pieces of the array. All right? So that's that. Do I want to go to code yet? Let's see. Not yet. Okay. So that's the start. That's the syntax to declare an array, and this is what it's going to look like in memory. Every piece is called an element. And then let me show you fancier ideas. So if you want an array of strings, you just say string array name, and then you give in brackets the size. So you can have any type inside of your array. It's just that's the first thing you say. If I want an int array, I say int R7. If I want a double array, double R7. Put any type of things inside the array, and you can initialize, you can give it an initial size with numbers within those brackets. There we go. And so, for example, just like int R of size 3. It's weird that the size goes somewhere different than the type stored inside, but you'll get used to it. So what this line does, again, is it makes something called R in memory that holds 3 things, really 3 boxes, but they're all next to each other. Indices 0, 1, and 2, all set to garbage. All right? Just like normal variables. It's just a bunch of things at once with one name. Okay? If you would like to go somewhere and give it a value at a certain index, you say its name, and then you put brackets, and you put the index you want to visit on the left-hand side of an assignment, and then you give it a value. Right? So if I wanted to set R of 0 to the number 1 or something, I could do this. R of 0 equals 1. And that would change it to hold a 1 here, and now I can actually get something out of works. All right? So that's this syntax, it indexes into the array and sets the value. That's what we're doing. Into R and sets the value. I don't know how I want to put this. And sets the value. That's sitting there. If you have a long array, it's kind of, I mean, you could do this in a loop now. That's fine. But if you have an array that you just want to immediately give values to, you can do it like this. You can say int r of 3 equals, in curly braces, what you want it to hold. So that just declares and initializes it all at once. You can be like int r of 3 equals 1, 2, 3, semicolon. And then it makes r for you, and it initializes each piece. There's 1, there's 2, there's 3, and it's happy. All right? Technically, that's redundant to put the 3 here because like you gave 3 things. So C++ has some shorthand if you want to do it that way and give it an initial value all at once. You can just leave out the number as long as you give values, and it'll just be like, all right, you wanted 3 things, I'm making you an array of 3 things. All right, so this would be this syntax. Something like, I don't know, let's make an array of doubles or something. Double A2 2 or something, I don't know, bracket equals some stuff. 3.14, 5.67, So that would make in memory array A2 holding doubles, index 0 holds 3.14, index 1 holds 5.67. Okay, so that's that syntax as well. Any questions about any of that so far? Is that okay enough? Yes.
So I can't help but notice that to declare and initialize an array, we're using the curly brackets.
Mm-hmm.
Could you then put like, I don't know, like an if statement or something within those curly brackets as well, or is that not?
No, this is strictly going to hold those values only.
So it's a different set of curly brackets.
Yeah, this is array curly brackets. That's a good question. You could put expressions that become answers, I think. But it could be like 0 plus 1, 2 plus 2, things like that.
You could put like x plus 2 or something in there?
I have a feeling you can. I've honestly never tried it. But I think it should be possible. I encourage you to try it. See if it compiles. Morally, that should be okay. But I'm not sure. But yeah, it's array-specific things. That syntax. It's overloaded syntax is the term for that. Good question. All right, yeah, you can't just put arbitrary code in here. But with that in mind, here's a quick demo. Let's make an array that can hold 10 numbers. Let's get 10 numbers from the user, and we'll print them all back out. Let's solve that problem that I was talking about before very simply with arrays. All right. So I'm going to make an array, be like that can hold 10 things. So I'll be like int r of size 10, and I'm going to fill it in with whatever the user gives me. And then suddenly I have an array that has space for all these things, and I'll fill them in. So, I don't know, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the indices into this array would be 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 10 total. All right? So let's get an array from the user and just print everything back out. Let me show you how to do this with a loop. That's why we need to study loops first. Alright, so let's make that array, int r size 10. So now r is an array of 10 ints, has the capability of holding 10 things, and the valid indices are 0 through 9, remember. So those are the ones you can talk to and ask about. Alright, now my goal is to get 10 numbers from the user and put them into the array. And put them into our question. Yes?
The x plus 3 does work.
Oh, nice. Thank you. So I'm glad. That's about as fancy as you can get within those curly braces, I think. Nice. So I want to get 10 numbers from the user, put them into the array with cn statements. Watch. It's not hard. It's all right. For int I, now I instead of like iteration variable stands for which index do I want to go to? I equals starts at 0. I is less than 10, I plus plus. Now I will range between every valid index of R. And let's fill it in. Let's be like, all right, so I is the current index, that's what it stands for, the current index of R that I'm trying to fill. So let's ask the user for the next number. Enter the next element, and all right, int next element, cin into that variable, and then place it at R of I. R of I equals whatever next element holds. See how this will fill in R of I with a value? Isn't that cool? Technically, you didn't need to make this next element variable. You could have just been like, you could have just been like cin into R of I, but that's a lot at once, I think. You could do it that way, but this way works. And then, yeah, so now we've got 10 things. Now every index of R has been filled because we let I range from 0 to 9. We asked for 10 elements total. And now let's print out everything. Print out all the elements of R. And so, honestly, this is kind of a silly program, but we're going to make it fancier in a second. So let's just do it all over again. So iterate through all the valid indices of R, 0 through 9, and just be like cout R of I. There we go. Or let's do them all on the same line. So print them with spaces in between and then break the line at the end. Question.
Why not just do cout R of I while you're getting each element?
Yeah, you could have just done that, but I'm going to make it fancier in a second, so I want to show us how to just make multiple loops that go through the array. Yeah, it would have been easier. Honestly, you didn't even need to make an array for doing just this. But this is to show that everything is getting filled in properly. So let's see, here's the code. Here's me running. Enter the next element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay. And there it is. It got them. It filled in R of I, each index of R, those things, and then it printed them all out, 1 through 10. All right. So any questions about this code? To make enough sense, we're filling in that array that we declared up there that's hard to show all at once. There. That's the first thing I want to do. Technically, you didn't need an array for that, but let's do some fancier things. Let's get the sum of all the variables that were given to us. So like if this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make a sum variable that starts at 0 and like shove them all in there. So that we like sum equals 0. Okay, now it's plus the 1. Sum equals what it was plus the 2. Now it's 3. Now sum equals what it is plus the value in this index. And now it's 6. And now it's 10. Dot, dot, dot. So bring them all in, each index. And then once they're all there, the sum has the final sum of every value that the user typed. So that'll be fun. Let's do that one. And again, it will be a loop. I want to loop over the indices of the array to sum them this time. So sum of the elements of R. All right, so let's go through every valid index for int. Let's do j this time. Why not? For int j equals 0, j is less than 10, j plus plus. So we want to have a sum variable at the start that starts at 0. I want to just keep adding in R of I into the sum variable, whatever it is. Sum, take yourself and add in whatever R of I holds. So after this loop is completed, we visited every index of, R of j, because I'm using j. After this loop is done, we visited every index of R, and suddenly sum holds the sum of all those things, all the values at those indices. So cout sum, sum and del. And so let's run this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So apparently the sum of all those numbers is 55, which I think is the right answer. But that's me iterating through every index in that array and doing something with it. Does that make sense? It's also super easy to get the average, right? Once you have the sum, you can get the average very quickly. Average of all the numbers is sum divided by 10.0, right? Because we want to do double division. So that'll print the average very quickly, and that'll work. I guess it'll be 5.5. I don't have to recompile it. I'll do it next time. But you get the idea. That's that one. Are we ready for the most complicated example? To find the minimum value in the array. All right. So here's the algorithm for finding the minimum. All right. First of all, you need to notice some stuff. We're eventually gonna we need to make a variable, right? That's going to hold the true minimum eventually. We need to make space to hold the minimum. So here it is. Let's make that space. And then we have to notice a few things. So first of all, we have no control over what the user is typing and putting in this array. So the minimum could be the first element, could be the 1 really, or it could be like the middle element if I made this -6. It could be the last element if I made it -10. So I have no control over where the minimum is, which means I have to check every single index because the minimum could be anywhere, any one of those. All right, so that's the first thing to notice. So I have to loop through the whole array, must check every index because the min could be anywhere. And the strategy is, the algorithm for finding the minimum, this also works for maximum, is you just start by making a guess. All right? Just guess that your first element, your 0th element at index 0, just guess that that is the minimum. Just put that in min, and then go through the rest of the array and update your minimum guess as necessary. All right? So that's going to be the strategy. So you make a guess at the very start. Guess that the 0th element is the minimum. In this case, it is. Guess that the 0th element, because that could have been the minimum, just guess that it is right now, is the min. And then, because the minimum could be somebody else too, update that guess if you find a better guess for the minimum. All right, update the guess as necessary. Update the guess as necessary. I hope you see where I'm going with this. So all right, if we guess that 1 is the minimum and this is what array looks like, what R looks like, then we're going to visit every other element and notice our guess was a good guess. I don't have to change this. Still 1 by the end of it. And so the true minimum, after you've given everybody a chance at winning out for the min spot, the true minimum is in the min variable. So 1 will be the final answer. But the goal is you're going to iterate, right? Check the 2. How does that compare to 1? Okay, it's bigger. I'm not going to update. It's not a better guess. But if this was -3, then you notice it. Then you're compare that to my current guess to the minimum. This one's smaller. So I think -3 is a better guess. I'm going to put -3 in my minimum variable. See that? And then you'll just keep iterating. And maybe that wins out. Maybe that's going to be your final minimum. You see how if you've given everybody a chance, then the true minimum will be the answer at the end, once you've seen everybody. So maybe there's a -10 at the end, and that's the final thing that you compare. And then it's -3 versus -10. Okay, -10 wins. Let's update it. Our guess is the minimum. That's -10 instead. That's the strategy. Does that make sense? By the time you visited everybody, you give them all a chance, your guess is the true minimum. All right. With that in mind, let's do it. So I need to get the min element. And this all works for max too, it's just the opposite. So I need to make space for the min, int min, and the strategy is guess that the first element is the minimum. Guess that index 0 is the min element. So guess that R of 0 is the real min. It may or may not be. We're going to try everybody. And now, let everybody else have a chance at being the min. Compare our min to every other index. So for int I equals, I can start at index 1 now, right? Because I've already used index 0. Put that into min. I is less than 10, I plus plus. And then we want to update min if we see a smaller element at R of I. smaller element. So I'm looking at an array index right now. I've got an index that I want to compare my min against. So if r of I, whatever I see right now, if that is less than my min guess, update the guess. All right. So min equals ri at this point. If I found something smaller, make it the min. So ri is smaller. That means that it's a better guess for the min. So save that into min. We found a smaller value. And so as long as you keep updating and putting the min that you've seen so far in the min variable, by the end, you will have the real minimum. All right? So you've gone through everybody, you've given them all a chance. Once this loop is done, after we visit every element, min holds the true minimum. The true minimum element in R. All right, so cout min. All right. Any questions about this before I show you it working? It's just we're going through the array, giving them all a chance to be the minimum. We guess that the 0th element is the minimum because we need to put something in there to start the whole process off. Technically, I guess you could put positive infinity as a starting value if you wanted to, and then just go through everybody, but that's hard to get in C++. This is easier, I think. All right, so let's do 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The minimum is 1. Like, it starts out as 1, and then it just never changes because everything's bigger. We never hit this if statement's body. Okay? If I rerun it, though, and I'd be like 1, 2, negative 3, 4, 5, 6, 7, 8, 9, 10, then the min is negative 3. You see how it's finding it? It's like, all right, start it with 1, and then once you see something smaller, update. We hit the body for that negative 3 element. We made negative 3 the min. And then everybody else was bigger than negative 3. So the final min was negative 3. But it'll just keep updating. 1, 2, negative 3, 4, 5, 6, 7, 8, 9, negative 10. It'll just keep updating itself. So it starts off at 1. It's like, all right, negative 3 is smaller. Set that to min. Oh, negative 10 is even smaller than negative 3. So again, it'll hit this body and be like, all right, my min guess is negative 10 now. And that's everybody. So negative 10 wins. Do you see how that's going to give us the true minimum by the end of that, all of that? Any questions about that? It's the most complicated algorithm, I guess, for this slide. Is it making sense? So that's the strategy. I think you can imagine how you can change that to find the maximum element, right? So with that in mind, we've learned a lot. Here's a question for you. All right, let's say that we declare this array, int blah of size 6. So blah, let's go back to blue, and I'll have you enter this in a second. Blah. It's of size 6. All right, here we go. 0, 1, 2. So it's got 6 elements, indices 0, 1, 2, 3, 4, and 5. And let's say that I tried to do this. I tried to access index 7 of blah, right? So first of all, index 6 doesn't even exist, and I'm trying to go to 7. So these are like ghost indices, don't really exist in the array. What do you think happens? Debate with your neighbor. I'll go to the by clicker page and have you guys enter in, and I'll stop the attendance once this is done, so do that if you forgot. What do you think? Enter in your answer. What's going to happen if I run these lines after declaring blah like this? I'm accessing a ghost index. What should happen? Feel free to try it if you have time, but in your mind, what should be happening maybe is another question. If only. So, yeah, you've got options. Like, maybe it just stalls everything. Yeah. You see how weird this is. This is why we're talking about it. You don't want to do this, but I think you can imagine if you get a loop wrong, you might accidentally go here. Yeah. This is why we need to talk about this. All right. Is that enough time to get a guess in? Take 5 more seconds to click something if you want to. All right. We're thinking B, and that would make sense. That would make so much sense. So let's try it. Let's try it. Did we try it? So let's see here. So thank you for your guesses. Thank you for your attendance. I want to be here later. All right, let's try it. I call this out of bounds.cpp because we're accessing an index of this array that is not within the bounds of the array. So, all right. Int blah of size 6. And then I want to do this. All this code. Blah 7 equals 42. Print it. Whee! Get some warning signs. Thank you, compiler. It's trying to look out for me. Bounds. Bounds. Let's see. Ooh. I do see 42, but I do get a runtime error as well. So that is technically an answer. It's like, oh, stack smashing detected terminated. I don't even want to explain what that is. Ask me in office hours or after class if you want to know what that is all trying to say. But that's disgusting. All right, so it's looking like B is the answer. But oh man, do I have something to show you. Let me wrap blah around some stuff. Let me make an array of 42 characters, and let me make an array of 42 doubles wrapped around blah. Ooh. And now let me recompile and rerun. 42. Program ends just fine. It's happy. So that should make you feel very uneasy, I hope. It worked. It compiled. It ran. It didn't tell me any issues. But there was an issue. This index did not exist. So here's what just happened. First of all, the answer is D. Sometimes you'll get a runtime error. A lot of times, most times you will not, because you have other variables. So what's going on here is if you access this memory, first of all, what is it? It's memory that does not belong to you, right? You're going somewhere in memory that is not yours. It's not part of blah. Memory that does not belong to you. And C++ trusts you. It's like, all right, you're doing this. Obviously, you have a reason. Just do it, and I'll let it happen if I can. And it did. So what's going on here is the original time when there was nothing left, it gave a runtime error because I messed with memory that belonged to how main was trying to return. It noticed that, and it was giving a runtime error because of it. But if I wrap blah around with some extra things, now I have a lot more variables to work with. I've made a lot more memory inside of my program for myself. This index was part of one of those other arrays. I was just writing to memory that was like characters or a double, and I wrote an int's worth of data, first of all. So I just clobbered 4 characters, because a character is a single byte, or I clobbered half of a double, which is disgusting and wrong in so many ways. So that's what happened. I just messed with somebody else's memory, and I shouldn't have. Okay, does that make sense? And there was enough memory when I made more things, and so it didn't even stop the program. But if you tried to like iterate through one of these arrays, you're going to get a weird value for one of those indices, or multiple. Okay, so that is the problem, yes?
What if you made the not an array, just a regular double?
That's probably going to be fine too. It'll write to, maybe that's the double deal, it'll write to half of its memory. It's fine. This is just to ensure that we make it work. But yeah, you can like maybe put 2 doubles around blah. There's a way. all you needed was 8 bytes, so technically you could have just made one double. As long as it got placed by the compiler in the right spot, you would have written to that memory. This is a problem for later in the class, worrying about what's in what part of memory. We'll get to it. But it's good to be thinking about it. And so what happened, the reason why it's not always a runtime error, the reason why it sometimes works is the second you do this, the second you disobey the laws of C++ and all that is holy, you have invoked what's called undefined behavior. All right, this is a technical term that's defined in the language specification for C++ and many other languages. You can totally do this. You can access an index that does not exist. You can access R5 when the array only goes up to index 4. Totally fine. But of course you should never do that. That's a bad idea, even though it might work. Because the second you do that, you have invoked the wrath of undefined behavior. So you're now writing to somebody else's memory, and if the compiler notices that you broke the rules like that, it's actually allowed to optimize away your code in any weird way that it wants to. So technically, it is within the specification of the C++ language for you running that program to have it delete everything on your hard drive, or replace them all with SpongeBob memes. Everything that you own. That is within the laws of the compiler at that point, because you have invoked undefined behavior and anything goes at that point. All right? It's usually going to work. It's usually not going to cause an issue. It might mess with a variable and you didn't need that variable anymore. But it is so subtle that I want you to just feel how wrong this is, internalize the pain, and make sure that you don't do it. Always watch out. Make sure your indices are proper. All right? So I think that's all that I wanted to say about that. Any questions? It's a weird example, but it happens a lot. If you forget, if you make a less than or equal to, suddenly you're out iterating past the end of an array, and weird things might happen. This is what you go and check for. All right? That is the idea. So with that, I think that's all that I wanted to say as far as lecture goes today. We'll do more of this next time. More array stuff, more vector stuff. First thing I want to do is release your next lab. Lab 3, this will be due week 7. Week 7. So there's a reason I'm giving you so much time. It's because we got a midterm. So let's talk about the lab first, and then we'll talk about the midterm. All right. This one is about loops. Lab 3. And so even though it's going to be due after the midterm, you should use this to practice. So please do the lab if you can. I might ask you a question about some of the things that you'll be doing on it, because I covered them in lecture anyway. So let's go to the starter code. Starter code 40, lab 3. It's trying. There it goes. So here's starter code. Got 2 files for 2 parts. All right. First part, I would like you to draw a right-leaning right triangle. I drew a left-leaning right triangle. You got to draw a right-leaning right triangle. So here's what it should look like. You're going to enter a size, and then the size is how tall it is, how tall the triangle is that you're about to draw. You're going to draw it with stars, and it's going to be right-leaning. So on this first line, there's going to be 4 spaces and then the first star. On the next line, there's going to be 3 spaces and then 2 stars. 2 spaces, 3 stars, 1 space, 4 stars. And then the last line is all 5 stars right at the beginning. Right? So that's how you do that. Size 8 is as you would expect, but it's leaning to the right. Right? I showed you a left one. You got to do the other way. And then you got to handle some small ones, like size 2 should work. It's been an hour. All right. Thank you. Let me figure out how to fix that. I did ask the IT people. They made a little ticket, and they will fix it eventually. But thank you for being on your toes. Okay, yeah, this way doesn't work. I've learned that button doesn't actually do anything. Oh, all right. Never mind. If it's happy, let's keep going. Let's see that. That messed a few things up. Now Zoom is in a weird place. Hello, Zoom. Zoom. Hello. There we go. Go to the bottom. There we are. All right, back here. So size 2 is super small. Size 1 is just a single star. A size 0 triangle prints nothing. Okay? So you'll watch out for that. It's just practice with if statements as well as loops. But here is It's all in the file. There's some comments. Look into the comments. So I'm getting the size, and so now, let's see. If the size is less than 0, I want you to stop the program. You can use you can return immediately or just call exit. When you exit, you should give back a code of 0 because anything other than 0 means bad things happened and the autograder gets confused. So either return 0 or call exit with the 0 argument. Okay? When you're stopping the program early there. If it's a bad size. Otherwise, you got a normal size that you can work with. Print that leaning right triangle of that size. And my hint to you is read this comment. It should help with your implementation. All right. So that is your triangle program. Any questions about that? So, a couple loops and an if statement or so. That's for that one. And so compile and run as usual. We good with that one? That's the first part. That's the easiest part. Then we have a graphing calculator program. Woohoo! So, here is the idea. You're getting something from the user. You're getting a number from the user, and the number is the choice of graph they want to see displayed. So they're going to enter 0, 1, or 2. All right? 0 corresponds to, if they enter 0, you're going to graph this function. Y equals, it's weird so that it looks nice on the terminal screen. Y equals 0.15x squared minus 3. If the user enters 1, you're going to graph this one. It's a cubic function. And if the user enters 2, you're going to graph a little sine wave that's looking cool. So here is the output that you should see for input 0. This is your graph. So in addition to drawing the graph and the axes meeting, you're going to draw the individual axes as well. Little pipe characters or dash characters for that. And here's the other one. Here's the cubic function, option 1. Looks like that. That's what you should see exactly. And then option 2 is the sine wave. And so you're going to use the sine function in CMath to plot this. Okay? So that's what it's going to look like. And then the rest is in the code. So I've given you a lot. You're welcome. I've set up the loop for you already. So your job is just to plot things. All right. So you got a coordinate right now. If you're in the innermost loop, you've got an XY. And it's your job to see, is this on the graph? Depending on which graph the user asked for. Is this on the graph? Is it on the axes? So the side axis or the middle axis meeting? Or if it's none of that, it's just empty space. All right. So here are your goals. Remember to do the rounding. Got to round. Read the comments. It should help. Because it's never going to be the case that the square root of something is a whole number, most likely. You got to shove it to a whole number coordinate, though, by rounding. So if it's on the graph, print a star, and then keep going. Just let it fall through. Otherwise, if it's not on the graph, what you got to do, you'll have to fix this ordering. But if x is 0, that means you're on this line right here, the top or bottom part of the x equals 0 line. That's your graph. So draw that. Print a pipe character if it wasn't already on the graph. If y is 0, that's the other way. That's the horizontal axis. That's this one. You want to print a dash character. If they're both 0, so you'll have to reorder these if statements. If they're both 0, you should print the axes crossing with a cute little plus sign. So this one, the graph's in the way. But for this one, you see the plus sign there. So the plus should take priority over the other axes. And then if none of that's true, it's just it's blank space. You got to move over so that you're ready for the next coordinate on the next round of the loop. All right? But that is what you print. I've given you the loops already. It's just mess with that. Take the coordinates and check it. Check it if you want to check it for if it's on the graph and plot it. Otherwise, check if it's on an axis. Otherwise, print a blank space. All right? And then after each row, you got to print a new line so that you're ready to graph on the next y equals whatever line. Any questions about this? So it's going to be fun. It's going to mess with your mind a little bit, but hopefully the comments are telling you what to do. Any questions about anything I've said so far? Does it make enough sense? All right, so that's all that, and so you're making 2 files, turn them both in, and graphing calculator is worth more because it's harder. That is that. All right, so that's your lab 3. We ready for the midterm info? All right. So, reminder, you have a test. So down here, I'm about to release a new module. It's going to be the midterm 1 module on Canvas. I'll release these two things today. Don't look at this. Don't look at this date right now. It's all wrong. But eventually, it's going to be on Canvas. You're going to come here. You're going to click this and take the exam. But this date is not correct. I'm not ready to release that yet. So publish module only. Here we go. So I'm releasing the info page and an extra credit assignment page right now that you can go and look at. So the page you're most interested in is the information. So we are in week 4. I promised that the midterm would be week 6. So 2 weeks from now will be a midterm. It will be in class on September 14th. So the latest day we could possibly have it, the Thursday of week 6. So the 14th is when it will be. You're going to have an hour and a half to take it once you click start. It's going to be timed on Canvas. You can come here and start it, but you'll have an hour and a half once you click start. That's how it will work. And let's see. So that's the logistical information. In class, the 14th, you come here, you click start, it'll be available. All right. Here are the topics that will be on the midterm that you should expect to see questions on. Lectures through week 5, not including functions if we get to those. Arrays and vectors will be the last maybe topic that might appear. So with that in mind, we have Zybook stuff, chapters 1 through 4. Those chapters involving those things, and then lab 0 through 3. So I know lab 3 is not due, but you should do it still because I'm going to ask you about loops. Definitely asking you about loops on this midterm. All right, so here are topics that you should be familiar with. I know arrays and vectors are close to the midterm, so if I ask you anything, I promise that the questions will be easy. I'll save harder ones for the second midterm about those topics. Okay, so those are the topics. The format of the midterm will look like this. It will have fill-in-the-blank questions and coding questions. Or you'll paste in code. So get practice right now, I'm telling you, because everybody's using a different terminal editor combination right now. Have you tried to copy and paste from the terminal yet? Because this is something you're going to have to do. It's going to be on Canvas. Get ready. Figure out how to paste code into a text box. All right? If you're going to work on the server, for example, figure out how to get it out of Nano, get it out of Vim, and onto a text box. I can show you how if you're struggling. But get ready so that you're not trying to Google how to do that on an exam, okay? Because it is not, for some, like for putty, it's not obvious how you do that. So that is that. And then the test, like the real world, will be open book and open notes. So you are welcome. The only thing you can't do is like talk to somebody on Discord. You can ask me questions, obviously, about the questions, but don't like talk to somebody else in the class or some AI chat thing. It's an exam. Okay, so that is the format, and here are some sample questions from last semester. So study this, and here are some questions that you should expect to see similar ones to. So that is the midterm. That's the date. That's the time range. Any questions? Fair enough, I hope. All right, so that's that. And then with every exam, I like to give an extra credit opportunity. So this is an extra credit opportunity that will be worth up to 2.5% extra credit, and it will be due for once. It will be a midnight due date for everyone, the midnight before the test comes out. So the 13th at 11:59 p.m. is when this will be due by. It is not a normal assignment, so if you have an extension, this does not apply to the extra credit. Everybody's due date is the 13th at midnight. Okay, so. No late submissions, and here's what you can do. It's me forcing you to study, honestly. So make a review video, and then you'll post it here in the reply section. So make a review video to help your peers review for the exam, and it will also force you to study for the exam too, so it'll help you too. You don't have to like make a fancy video. You don't have to edit anything. Just like click record and post whatever you got recorded, right? If you wanted to. Yeah, if you wanted to go crazy, your peers would love you. I know. So do whatever is within your power, whatever you're willing to do. Here are your hard requirements for this review video. All right, so it's got to be a review first of all. So you got to have some examples of stuff that will appear on the exam. Don't like talk about things that are not going to be on there. Be creative. That's how. Make some colorful examples that will help people study. And then just like demonstrate stuff, right? You're reviewing. So explain what you're doing. Talk about what's going on. Maybe draw things with your mouse if you want to. Pretend that you're me and you're giving a lecture. That might help. But yeah, just hopefully the word review makes some neurons fire in your brain. Just go in that direction. All right. So if you want half of that percentage, if you want 1.25% extra credit, make at least a 10-minute video that reviews stuff. And then if you want the full 2.5, make at least a 20-minute video that reviews stuff. So hopefully it's clear, but if it's not, you have to make something new to get extra credit. You can't just read off my slides or read off your answer to a lab or something like that. You've already done that. That's not extra, yeah? So you got to make new code, write new slides, make new diagrams, something. I'm pretty accepting of whatever you choose as long as you do something new. So if you are at all confused or concerned about what you're going to do if it's not enough, talk to me and before you get a 0, okay? So I want to make sure you're going to get the extra credit that you deserve if you want to do it. But those are your requirements. And I'm using OBS right now. That's a fun app. A lot of streamers use it. It's pretty easy to use to record yourself. Zoom also, I assume you have Zoom installed since we were all doing stuff during the pandemic, I'm sure. Zoom has a record feature as well. It can record to your computer. You can upload that to YouTube or something. Or I think you can upload it straight to Canvas. But yeah, as long as I can view it, make sure it's a public link if you put it somewhere like YouTube. Make sure everybody can see it. But that's the idea. Or an unlisted link as well works, just as long as somebody who has that link can go and look at your video. That is your review extra credit opportunity. Any questions about that? All right, I believe that is everything that I wanted to talk about. So we made it. Got a new lab now, so the rest of the time is yours to work and ask questions.